Discover how to efficiently manage memory in Claude-based Python agents. Learn dynamic memory allocation techniques to boost AI performance and reduce latency.
Welcome to our deep dive into optimizing memory in Claude Python agents. Did you know that poor memory management can lead to increased latency and decreased performance in AI-driven applications? In today's fast-paced digital landscape, efficiency is key. In this video, we'll explore how mastering memory management in Claude-based Python agents can significantly improve your application's responsiveness and scalability. By the end of this tutorial, you'll have the tools and techniques needed to efficiently allocate and manage memory, ensuring your AI applications perform at their best.
In Python, memory allocation plays a crucial role in how your programs perform. Dynamic memory allocation allows Python programs to request memory from the operating system at runtime, providing flexibility but also requiring careful management to avoid inefficiencies. Static memory allocation, on the other hand, reserves memory at compile time, which is less flexible but can be more predictable. Understanding these concepts is vital for Claude Python agents, as they often need to handle large data sets and complex operations. By mastering memory allocation strategies, you can ensure your applications are both efficient and robust. To optimize memory, you must first understand where and how it's being used. Python offers several powerful tools for memory profiling, such as memory_profiler and obgraph. These tools allow you to monitor memory usage in real time, helping you identify bottlenecks and inefficiencies. By visualizing memory consumption patterns, you can pinpoint areas for improvement. Effective use of these tools can transform your approach to memory management, providing insights that lead to more efficient code and improved application performance. Garbage collection is a fundamental aspect of Python's memory management. It automatically reclaims memory by deleting objects that are no longer in use. However, inefficiencies in this process can lead to memory bloat and performance slowdowns. By implementing effective garbage collection strategies, such as tuning the garbage collector's thresholds and managing object reference cycles, you can reduce unnecessary memory consumption. Understanding and optimizing these settings will help ensure your Claude Python agents run smoothly and efficiently.
Choosing the right data structures can drastically reduce your application's memory footprint. Python offers a variety of data structures, each with its own memory and performance characteristics. By selecting the most efficient options, such as using sets for unique collections or tuples instead of lists when data immutability is required, you can minimize memory usage. Additionally, leveraging data compression techniques and Python's built-in libraries can further optimize memory consumption, ensuring your Claude Python agents are both fast and efficient.
Memory leaks occur when a program fails to release memory that is no longer needed, leading to gradual memory consumption and potential application crashes. Identifying and managing memory leaks is crucial for maintaining optimal performance. Python provides tools and techniques to detect and prevent memory leaks, such as using tracemalloc to trace memory allocation and obgraph to visualize object references. By regularly monitoring your application's memory usage and implementing preventive measures, you can ensure that your Claude Python agents remain stable and efficient over time.
In AI applications, where data processing and model training can be resource-intensive, efficient memory allocation is essential. By adopting best practices, such as using memory management libraries like NumPy for numerical computations and Pandas for data manipulation, you can optimize your code for AI workloads. Regular memory audits and performance profiling can help balance memory usage with application speed, ensuring that your Claude Python agents operate seamlessly even under heavy workloads. Stay ahead of the curve by continuously refining your memory management strategies in response to evolving AI technologies. Let's explore how memory optimization is applied in real-world AI scenarios. In this case study, we examine a large-scale AI project that faced significant memory challenges during data processing and model training. By implementing dynamic memory allocation techniques and optimizing data structures, the team was able to reduce memory usage by 30%, enhancing performance and scalability. By learning from these practical applications, you can gain valuable insights and strategies to apply in your own Claude Python agents, ensuring they are both efficient and robust.
As we wrap up this tutorial on optimizing memory in Claude Python agents, let's recap the essential techniques we've covered. From understanding dynamic memory allocation to implementing garbage collection strategies, these skills are crucial for enhancing the performance of your AI applications. We encourage you to apply these techniques in your projects and share your experiences. If you found this video helpful, please like, subscribe, and share it with others who might benefit. Your feedback is invaluable, so leave a comment with your thoughts or questions. Let's continue learning and optimizing together.